In the previous video, I showed that the purity when classifying all the records by homeownership. You can check out the previous two slides for calculation of impurity of the other two classifications. With that, we now have the impurity when classifying the entire dataset with each of the three attributes. The result shows that income affects the default rate the most, so it is the most influential factor to a client's change of default. This is because income has the lowest impurity, meaning that this classification has the purest outcome in each split. Therefore, the split of income is the most informative in telling whether a client would default or not. So based on this result, we can construct a tree like this. Here, the number in each node represents the chance to default based on the records in a split. For example, without any classification, a client has 20% of chance to default. But if a client's income is low, the chance of default is 60% because 3 out of 5 records in that split default. Based on this tree, we can build a forecast model. Let's assume that we predict that a client would default if his or her chance to default is greater or equal to 50%. Then this tree makes the following prediction. First, if the income of a client is low, then we predict that this client will default. Second, if the income of a client is high, then we predict that this client will not default. Here, 50% is a managerial choice. The choice of this number is beyond the discussion today. You probably are not quite comfortable about the prediction that a client will default if his or her income is low. After all, if we apply this prediction back to our data, this prediction is only correct 60% of the time. This is primarily because the records are not pure enough in the low-income case. So we can further classify clients with low income to see if we can obtain pure classifications. First, let's classify low-income clients by home ownership. There are 5 low-income clients and 3 of them default. There are 2 splits because there are 2 possible outcomes for homeownership. The first outcome is that the client is a homeowner. There are 2 clients in this case, so n equals to 2. Among the 2 clients who are homeowners, one default while the other does not. So we can calculate the entropy for this split, which turns out to be 1. The second split is the case where a client is not a homeowner. There are 3 clients in this case, so n equals to 3. We can calculate the entropy for this case, and it turns out to be 0.9128. With the entropy for both of the splits, we can calculate the impurity for homeownership, which turns out to be 0.9510. Following the same procedure, we can calculate that the impurity for marital status is 0.4. Let's have a quick summary here. First, we know that the impurity when we classify all of the records by income is 0.4855. Second, if we further classify clients with low income, we find that the impurity of the splits are these 2 numbers. These results make us determined to further classify low-income clients by marital status for 2 reasons. First, marital status has the lowest impurity among all possible classifications under low income. Second, marital status has an impurity that is lower than the impurity of the previous level of classification, which is income. Notice that we will not further classify clients with low income if the second condition does not hold for homeownership and marital status. In other words, we further classify a group of records only if doing so results in a lower impurity. We can now update our tree. Now we further classify low-income clients by marital status, and we can see that the impurity gets lower. Now we find that if a client has low income and he or she is single, then the chance of default is 50%. This 50% comes from the fact that there are two records in this split, and one of them default while the other does not. We also find that if a client's income is low and he or she is married, then the chance of default is 100%. If the low-income client is divorced, then the chance of default is 0%. We don't need to further classify any split that has zero impurity, such as married and divorced split after low income, because the records in those cases are pure. However, if a client has low income and single, the client has 50% chance to default. If we're going to build a prediction based on this, it is probably going to be quite inaccurate. In fact, if you move 2 slides up, you will find the impurity for this split is 1. So there might be value to further classify this case. There's only one attribute left now, the home ownership. If we further classify the clients with low income and single, we will result in this tree. I leave it for you to check that the impurity of this classification is 0. So you can observe that impurity gets lower as we further classify the results. The last classification by homeownership results in 2 pure splits. For example, if a client's income is low and he or she is single and not a homeowner, then 100% of the clients in this case in our data default. Based on this tree, we can make the prediction which I marked in red. For example, if a client has high income, then we predict that this client will not default, regardless of his or her marital status and home ownership. If a client has low income and is married, we predict that this client will default. You probably realize that calculating entropy and impurity is a very tedious and repetitive task. So let's see how Excel can better streamline this process. Please open example.xlsx on Blackboard. You will find the 10 records in this example and this template in the spreadsheet. This is a template to calculate impurity of a split. First, you can enter the name of the classification here. We will store the final value of impurity of this classification here. This block tells the types of splits this classification has. The number of rows in this block needs to be the same as the number of splits this classification has. For example, if we are classifying by income, then there are 2 rows as you see here. But if we are classifying by marital status, then you will need 3 rows. This block counts the number of records for each outcome that we measure. In this example, the outcome we concern is default or not default. Finally, this block calculates the entropy for each split. Now, let's check out Excel to see how this works.